Okay, so lastly is coding, where you will map the discrete data from the quantizer onto a code in an optimal manner. So a compression algorithm may consist of only part of the stages. So not necessarily all parts have to be in your compression ratio. So the decompression can also be further broken down with the decoding, where you have the decoding and inverse mapping. Okay, so decoding, what you will do, you will reverse the coding by mapping the code to the original quantized value. So you will do the inverse mapping, where you will reverse the original mapping process. Okay, so post-processing can then be performed. Okay, so once you do the compression and then you do the decompression, okay, so output of the decompression, you can also do the post-processing to see the performance can be performed, where you will enhance the look for the final image. So sometimes when you do the compression, when you do decompress, your image will become blur, for example. So with this blur image, you can do the post processing, okay, so that your image can be enhanced to look of the final image. Reverse any pre-processing done before compression. So you can also eliminate reduce the artifact from the compression process. Example, okay. So the goal of data reduction is to prepare the image for the encoding process by eliminating any irrelevant information. Which information is irrelevant depends on the application. Okay. So the mapping process is important because image data tend to be highly correlation. So if one image value is known, it is very likely that the adjacent pixel value is also similar. Okay, so once you have an image pixel value, so the surrounding pixel value will be similar. So that's how you can reduce the image data. So it can be done by finding a mapping equation that correlates the data. So this type of data redundancy can be removed. So the common mapping used in compression is by finding difference between adjacent pixel and encode these bit values. Okay, we call it as differential coding. Or you can also use the PCT. Okay, or you can map it into frequency domain. So these mapping methods are reversible and therefore preserve information. So depending on the mapping equation used, quantization may be necessary to convert the data into form. Okay, so quantization can be uniform or non-uniform. So quantization process is not reversible, therefore some information may be lost. So this one, coding is used to generate the output data. So lastly, when you do the compression approach, technique, so you will do the coding. Coding is where you will generate the output. So it depends on the technique that they use. Okay, so if you use, for example, dictionary technique, so you will generate the dictionary. Okay, so with this dictionary, you will code, okay, your output image. So each quantized value will have a unique output value, and it is a reversible process. So there are two types, okay, either equal length code or unequal length code. So this one also depending on the technique that you use. Okay, either each of the pixel will be encoded with equal length or unequal length. Okay, so lossless compression method are necessary in some imaging application. Okay, because image medical image, the size is too big. Okay, so that's why you need to do the compression. Okay, although it is big, but it is not suitable to use lossy, because medical image, the information is very important. So you cannot lose any of the information. So that's why you need to use lossless. So in general, lossless compression method provide only around 10% file size reduction. However, lossless compression technique may be used as pre-processing and post-processing in compression algorithm. So this one, I think you can read by yourself. Okay, so we will look on the technique itself. Okay, so we only look on the lossless compression. So the theory behind lossless compression is this: an event that is less likely to occur is said to contain more information than an event that is more likely to occur. So for example, what is the meaning of less likely to occur? So for example, you have an image. Okay, so the pixel value may be 255. So 255 will occur only maybe twice. Okay, so maybe here and here. So we consider this is an image. So less likely occur means in your image, the pixel value of 255 only occur 2 times. But if more likely to occur means there will be occur 100 times. So maybe here 0, 0, 0, 0, 0, 0, 0. Okay, so in other words, less likely occur is the probability. Okay, if the probability is high, means that particular pixel value will occur more on your image. Okay, if less like high probability, more time to occur, but less probability means less time to occur. Okay, why it is important? Because if probability high, you will use less number of bits to represent the image, that pixel, that particular pixel value. If less likely occur, means you will use more bit. Okay, so that is the theory behind lossless. Less likely to occur means the probability is low. Okay, more likely to occur, the probability is high. So in your image, that particular pixel will occur more. Probability low, that particular pixel value will occur less. So if less likely to occur is said to contain more information. So low probability will contain more information. Okay, but probability high, so the information is not high. Okay, so we can relate this information coding. Events that are more likely to occur should be assigned in a few number of bits. more likely, fewer number of bits, most frequent, will use small number of bits. Okay, so this is how the lossless compression method been done. If that particular pixel occur more time, so you will use few number of bits. So automatically, so logically, your image will be reduced. If most frequent, then you will use small number of bits. Wait again. More likely, use fewer number. More likely to occur should assign fewer number of bits. The most frequent gray level should be coded with a small number of bits. So this is the same statement. So if probability low, you will use more bit. Okay, if probability high, you will use less number of bit. So automatically you will reduce the size of the image. So entropy is the measure of theoretical minimum for the average number of bits per pixel that could be used to encode an image. So if you have an image, so then first step is to calculate the entropy. Entropy is important so that you can measure the theoretical minimum, the minimum average number of bits to be used, number of bits, and that could be used to encode the image. So for example, entropy for n times n can be calculated as follows, okay, which is negative I equal to 0 to L less than 1, okay, probability I log to probability I. Okay, I is referring to the gray level. So PEI is the probability of the I gray level, and K is the number of pixels with gray value K, and L is the number of gray level. So L is the gray level. So if your image is 8-bit, then the total number gray level is 256. Okay, so you will get the entropy from the gray level 0 to 255. Then you do the summation of all the gray level, okay, by taking the probability, okay, and with this probability you get the log PI. So later we will see the example. So example, L is 8. L is the gray level. So meaning that you will use 3 bits per pixel. So let's say that the number of pixels at each gray level value is equal. So they have the same probability, which is P0 until P7, the probability is 1 over 8 because the value, okay, is equal. So to calculate the entropy, okay, is negative summation of I equal to 0, L minus 1 is 7, okay. So since the probability for each pixel gray level is the same, then 1 over 8 log to 1 over 8, okay. So you will get 3. So this tells the theoretical minimum for lossless coding for these images of 3 bits.